I really wasn't interested in manufacturing policy until I started to realize why manufacturing is so central to the future prosperity of the American economy. We're working right now on a project looking at how to kind of modernize the way that we think about manufacturing in the United States. There's essentially kind of two dominant camps, one on the left that I'll call the preservationists, who kind of have a defensive posture towards manufacturing. I think that we need to kind of put up barriers to preserve the kind of industries that we have today that have traditionally created middle-class jobs, good-paying jobs for middle-class Americans. The other side is what we call the Pollyannas, which are the folks that don't think that we need manufacturing at all in the United States economy. They're the folks that think that we'll kind of seamlessly transition to a post-industrial, service-oriented economy without manufacturing. The truth is really somewhere in the middle, and the fact is that manufacturing itself is a really integral part of the future prosperity of the American economy for reasons that are somewhat different from the traditional kind of labor-left, good-paying jobs rationale. One of them is that manufacturing is actually central to innovation in the economy. 2/3 of research and development spending, the kind of spending that leads to new ideas and new technologies, occurs within the manufacturing sector. And what you find actually is as manufacturing capacity moves abroad from the United States to other countries, research and development often follows to be close to manufacturing because there are many synergies between the two sectors. So there's really no way to separate innovation from manufacturing. They're really integrated in a way that we're only kind of starting to begin to understand. So let me give you one example. Applied Materials is a company in the United States that does one of the largest semiconductor manufacturing companies, and they also build the machines that are used to create solar cells. They recently created the world's largest solar private research and development facility in China, to be close to the manufacturing centers that are springing up in China for clean energy manufacturing. So this is an example of where we've lost a manufacturing edge in the United States, thinking that we can keep our lead in research and engineering and innovation. And in fact, what's happening is that innovation capacity is now moving abroad to be close to manufacturing. The United States is still one of the largest manufacturers in the world. We were actually just recently this year surpassed by China as the largest manufacturer in the world, but we still have about 20% of the global market share. One of the big issues in manufacturing, particularly over the last 8 years, is that we've lost approximately 5.5 million jobs in the manufacturing sector. So it's really been devastated ever since the 2001 recession, and employment really hasn't increased. And a lot of people will tell you, well, productivity is still increasing in the manufacturing sector, so the fact that we're losing jobs is not necessarily a big problem. They compare it to agriculture. You know, do we really want millions of Americans working in agriculture the way that we did in the 1900s? This is a story of productivity, of increasing output, etc. The problem is that in manufacturing, productivity has increased, but output is actually stagnating, or in many sectors has declined. So in 15 of the 19 sectors, manufacturing sectors that are measured by the US government, output has actually declined. Value added in those sectors has actually declined over the last 10 years. So we're in a period where productivity is increasing, but output is declining or is stagnant. And what that suggests is that it's actually really about international competition and the fact that a lot of other countries are becoming much better at manufacturing the technologies and the products that we used to lead the world in manufacturing. So here's an example. Manufacturing has actually, the rate of increase in productivity in manufacturing has not increased over the last 10 years from the 10 years previous. In the past decade, from the 1990s to 2000, while productivity was increasing, we also saw output increasing as well. Now productivity is still increasing at the same rate, but output is not increasing. And yes, one of the reasons is because we're producing the same amount of goods with less people, and which is something that you would expect with automation, with the use of high precision tools. Manufacturing is becoming much more of a high-tech enterprise in the United States. So we shouldn't necessarily expect many millions of more jobs to be created on the factory floor. But that doesn't mean that manufacturing is not a central part of the US economy, precisely because the only way that we're going to create the new technologies that are going to drive the industries of the future, such as clean energy technology, for example, is if we have the capacity to manufacture those technologies in the United States and integrate the new inventions and innovations that our scientists are coming up with into products that can be sold to other countries around the world. There is a disconnect with people who believe that we can stay competitive in clean energy, for example, simply through research and development without manufacturing. This is an experiment we've actually run in this country for the last 20 years. The United States invented nuclear power, the United States invented wind power, solar power, but all of those technologies have largely been massively scaled, produced, and commercialized abroad in places like Japan, China, and Germany. And as a result, the economic value that comes from producing those technologies and exporting them to the rest of the world is accruing to firms in those countries, even though the United States invented the technology itself. And you hear this from a lot of people in the media, for example. Thomas Friedman, the columnist of the New York Times, says, China, they can do the dumb manufacturing stuff. It's not that important. We'll continue to do the design, we'll do the research and innovation, and that'll keep us competitive in the global economy. And the fact is, it's completely the opposite. Research and manufacturing are integrated in a way that you just cannot separate. And the value that accrues to the national economy from those new technologies is going to come largely through manufacturing and exporting those technologies abroad. One of the things you hear a lot about manufacturing, about whether or not the United States can compete, is about labor costs. A lot of folks argue that the labor costs in the United States are just too high. We can't compete with low-wage labor, low environmental standards in places like China. Well, the fact is that in most advanced technology industries, advanced manufacturing, the cost of capital is actually a much greater portion of overall costs than labor. So, for example, in semiconductors, 90% of the cost of a new manufacturing semiconductor plant is about the equipment, the capital that you need to build the plant, not the labor. And if you look around the world at what countries are competitive in what kinds of products, if it was all about labor costs, then Germany would not be a competitive high-tech manufacturing power. Why are semiconductors largely manufactured in Asia, which we would normally think would have a high labor cost advantage for labor-intensive goods, but in fact they're really good at these high capital-intensive manufacturing sectors and industries like semiconductors. So the labor cost argument is oversold, and there's no reason why the United States can't be a world leader in manufacturing advanced technologies that are largely going to come about through automation and IT-driven manufacturing processes. The agenda for a manufacturing economy is first to recognize that it's a strategically important sector of our economy, and understand that the more that the supply chains for advanced technology industries in the United States are hollowed out, the less likely we will be able to produce the new technology that depend on those supply chains in the future. So policy responses would include investing in a science and technology infrastructure and workforce that is trained and has the skills to operate the kinds of IT-driven machinery and manufacturing processes that are going to be needed to keep the United States competitive in manufacturing, offering things like tax credits for research and development or tax credits for the establishment of new high-tech manufacturing facilities in the United States. These are things that other countries are doing around the world to great effect that the United States is reluctant to do, because whenever we think of this thing we call industrial policy, it's just something that's hands-off for the US government. But the fact is that other countries are actually using targeted policies to attract leading manufacturers into their countries and to grow their science and technology base in a way that's making their firms more competitive. One of the major criticisms is that the government can't pick winners and losers. This is the kind of big criticism against industrial policy. And what we're talking about with strategic manufacturing policy is not, picking a national champion. We're not going to say, this particular company is going to make the batteries that we need for electric vehicles to take off in the United States. But what we are saying is that there are certain sectors of the economy and certain industries in the economy that we think are going to be vitally important over the medium to long term in terms of building new industries and new technologies in the future. So for example, nanotechnology. We can maybe agree with Republicans and Democrats can agree that nanotechnology is a very promising area of research that has the potential to completely remake the way that we produce new technologies. Why shouldn't we be supporting that in a strategic way as opposed to, say, furniture? For example. That doesn't mean that we're going to pick one company that's going to produce all of the nanotechnology innovations, because we don't know where those innovations are going to come from. But we do know that it's going to be a strategically important sector in the economy. And we would argue the same for clean energy, for IT. There are sectors that are going to be important for reasons related to innovation and productivity, and they already have a track record of driving innovation and productivity. And those are the sectors that we need to be supporting.